Up to 80% of plastic in our ocean is transported from land to the sea via rivers or coastlines. The other 20% comes from marine sources such as fishing nets, lines, ropes, and abandoned vessels. If we want to tackle plastic pollution, we need to stop it from entering the ocean from our rivers. The problem is that we have hundreds of thousands of river outlets through which plastics reach the oceans. Thus, to prioritize mitigation efforts, we need to understand which of these rivers transport plastic to the sea, and which ones contribute the most. With this video, we will try to understand how plastics are distributed across the world's rivers, why some rivers carry a lot of plastics while others have very little, and which countries account for the largest share of plastic pollution. Let's begin by looking at how these plastics are distributed. A 2021 study found that rivers emitted around 1 million tons of plastics into the oceans in 2015. Around 1/3 of the 100,000 river outlets examined contributed to this. The other 2/3 emitted almost no plastic to the ocean. This study used high-quality data about wind and precipitation patterns and river discharge, plus factors such as the proximity of populations to the river, distance to the ocean, the slope of the terrain, and types of land use. These elements are found to play a much more important role than the size of the river basin itself. This means that many smaller rivers play a bigger role than we thought. This makes a massive difference to how we tackle plastic pollution. If 5 big rivers were responsible for most of the problem, then we should target the majority of our efforts there. But if this comprises thousands of rivers, we're going to need to cast a much wider net of mitigation efforts. To tackle plastic pollution, we need to know what rivers these plastics are coming from. It also helps if we understand why these rivers emit so much. In the chart we see the 10 largest contributors. This is shown as each river's share of the global total. 7 of the top 10 rivers are in the Philippines. 2 are in India, and 1 in Malaysia. The Pasig River in the Philippines alone accounts for 6.4% of global river plastics. This paints a very different picture to earlier studies where it was Asia's largest rivers, the Yangtze, Xi, and Huangpu rivers in China, and Ganges in India, that were dominant. We should examine the main factors determining the river's pollution level. First, plastic pollution is dominant where the local waste management practices are poor. This means there is a large amount of mismanaged plastic waste that can enter rivers and the ocean in the first place. This makes clear that improving waste management is essential if we're to tackle plastic pollution. Second, the largest emitters tend to have cities nearby. This means there are a lot of paved surfaces where both water and plastic can drain into river outlets. Cities such as Jakarta in Indonesia and Manila in the Philippines are drained by relatively small rivers but account for a large share of plastic emissions. Third, the river basins had high precipitation rates, meaning plastics washed into rivers, and the flow rate of rivers to the ocean was high. Fourth, distance matters. The largest emitting rivers had cities nearby and were also very close to the coast. Here's a real-life example. The Siliwang River Basin in Java is 275 times smaller than the Rhine River Basin in Europe and generates 75% less plastic waste. Yet it emits 100 times as much plastic to the ocean each year. The Siliwang River emits much more plastic to the ocean, despite being much smaller, because the basin's waste is generated very close to the river and the river network is also much closer to the ocean. It also gets much more rainfall, meaning the plastic waste is more easily transported than in the Rhine Basin. So, we've looked at the role of individual rivers, but how do these aggregate at the regional and country level? In the chart we see the breakdown of global plastic inputs to the ocean by region. 81% of ocean plastics are emitted from Asia. This should not surprise us given the fact that Asia is the world's most populous region, plus all of the top 10 emitting rivers were in Asia and most of the top 50. The distribution of plastic inputs is reflected on the world map. There we see each country's share of global plastic emissions. The Philippines accounts for more 36% of plastic inputs, while India for 13% and China for 7%. This is because the Philippines consists of many small islands where the majority of the population lives near the coast. People often find this global distribution surprising. Since consumers in rich countries tend to use a lot more plastic, people expect that they contribute a lot more to plastic pollution than they actually do. And it's not just about population size. Even on a per capita basis, rich countries contribute very little plastic to the ocean. European countries, for example, emit less than 0.1 kilograms of plastic per person. This compares to 3.5 kilograms in the Philippines or 2.4 kilograms in Malaysia. This relationship is shown on the graph here. On the y-axis, we have per capita plastics emitted to the ocean, and on the x-axis we have GDP per capita. We see the largest per capita contributors tend to lie in the middle of the income distribution. We can understand what determines each country's contribution through 3 steps. First, the amount of plastic waste that each country generates in the first place. Rich countries produce much more plastic waste per person than poorer countries. Most produce 0.2 to 0.5 kilograms per person per day. This compares to 0.01 in India or 0.07 kilograms in the Philippines. Second, how this plastic waste is managed. Low to middle income countries tend to have poorer waste management infrastructure. Waste can be dumped outside of landfills, and landfills that do exist are often open, leaking waste to the surrounding environment. Per capita mismanaged waste in the Philippines is 100 times higher than in the UK. When we multiply by population, giving us each country's total, India, China, the Philippines, Brazil, and Nigeria top the list. Third, is the probability that this mismanaged plastic waste reaches river networks, and then the ocean. The climate, terrain, land use, and distances within river basins affect the probability that mismanaged plastic waste is emitted to the ocean. The probability of mismanaged plastic waste entering the ocean by country is shown in the chart. This probability is much higher in countries such as the Philippines, Malaysia, and Sri Lanka than China or India. This is why smaller rivers in these countries play a larger role than we might assume. Many people think that rich countries ship most of their plastic waste overseas. But is this really true? The short answer is no. Many countries export some of their waste, but they still handle most of it domestically. For example, in 2010 the UK exported about 17% of its plastic waste, the US 5%, France 11%, and the Netherlands 14%. However, it is crucial to understand how much this exported waste contribute to plastic pollution. We don't know for sure how much of the plastic exported by richer countries ends up in the ocean. The probability that mismanaged waste ends up in the ocean varies a lot by country. Let's take the Philippines as our worst-case scenario. As we saw, if rich countries exported all of their plastic trade to the Philippines, 7% of it might end up in the ocean. If we also consider best-case scenarios, we could reasonably estimate that around 5% of ocean plastics result from trade from rich countries. In the end, identifying where plastic emissions are coming from really matters for how we tackle it. Rich countries emit very little, so they should focus on supporting low to middle income countries in improving waste management infrastructure. This solution is key to tackling plastic pollution. Unfortunately, an end to trade won't stop plastic pollution, since only 2% of the world's plastic waste is traded. Nonetheless, rich countries should ban the export of any plastics to other countries where it could be mismanaged. To stop plastic pollution in our oceans, we need a global approach to reducing plastic waste and managing it appropriately to stop it leaking into the natural environment. That is all for today. Thank you for watching. I hope you enjoyed this video. If so, please subscribe to the channel and leave a comment to tell us how you feel about this very important topic. See you next time.